I'm an AI engineer, and I just realized something kind of embarrassing. I've been paying for ChatGPT, Claude, using cloud APIs at work, building AI products on someone else's servers, while sitting on a laptop that can run this stuff locally. Two actually, two laptops. One flagship machine and one I genuinely forgot that I own. It's just collecting dust in a drawer. So I'm doing the obvious thing. I'm building a private AI on my own hardware. No cloud, no subscriptions, no data leaving my house. A proper Jarvis, if that's what you want to call it. This is the first episode of me trying it out. So if you have been curious about local AI too, this is what I have learned. Let's go. Quick context for why I'm even doing this. Every time you type something into Claude, ChatGPT, it goes to OpenAI service. Same thing with Claude as well, and Gemini, all of them. You pay per token, you hit rate limits, your data lives on somebody else's machine. That's fine for casual use, but that's not the issue. The issue is something shifted in the last year that I didn't fully clock until recently. Open source models like Llama, Qwen, DeepSeek got really good. Local 8B models now match GPT-4 Turbo Mini on most everyday tasks. That's zero cost per query then. And the hardware to run them isn't as exotic as you think. So if I can stop sending my data to somebody else's server, stop paying for those tokens, and learn how this works underneath, that's three good reasons to try. So why not? Now the question is, how do I actually run it? That's where the rabbit hole started. Turns out there are three serious tools people use to run AI locally. They all do the same fundamental job: load a model, let you talk to it, but they're built for completely different people. And I had to spend an evening figuring out which one was actually for me, which one is the right one. So the first one we have is llama.cpp. This is the foundation. So basically, it's the performance baseline that everything else is measured against. And it's pure C++, no dependencies, and runs on basically any hardware that exists. But the catch is, you build it yourself from the source. You configure it yourself, no interface. Ollama and LM Studio are both actually built on llama.cpp. They're wrappers around it. So when you use either of those, llama.cpp is doing the actual work underneath. And for my use case, it's an overkill, honestly. I want to use the models, not compile my own runtime. So that's why we move on. Next up, we've got Ollama, a plug and play LLM environment built for its simplicity and the speed. Basically, we just install it, run one command that pulls the model, another command runs it. That's it. Thing that makes Ollama the developer favorite is that it exposes an OpenAI compatible API on the local host. That's it. And most local AI tools like Cursor or OpenWeb UI, they target Ollama by default. So that's the thing, right? So if I'm planning to plug local models into code later, this actually matters to me. But the downside, right? The downside to this is it's CLI, command line first. There's no graphical interface for browsing models. You just have to know what you want to pull. Coming in just like that to local AI, that felt like a bit blind to me. The next one we have is my favorite actually. It's the LM Studio. It has the GUI option if you want the graphical user interface, and it's built for people who want to browse and evaluate their models visually. So basically, you just open it. It's like an app store for all the AI models, if that makes sense. So you search, you filter, you see the file sizes, you see whether it will fit on your hardware before you download anything. So just click download chat, no terminal involved. It also runs the same OpenAI compatible local API as Ollama. So you don't lose the developer angle, you just get like a graphical interface on top of it. Honestly, I went back and forth on this. Ollama is what most engineers I know use, and it's what I'll probably end up running long term. But for me figuring out which models are even worth running on my hardware, what fits, what's fast, what's good at what, I want to see it. I want a visual feedback loop. So that's why I'm starting with LM Studio for this video. Now let's begin with which local model should you run. So this is the main question that I've been having, and these slides just make it a bit more easy to understand what's going on. So the basic rule is the model has to fit in your memory. and only if it does, that's when we can run it. So model size has to fit your memory, basically what we said earlier. And if you're like me on a Windows machine, you can easily check your VRAM and then find out what works for you and what does not. But if you're on an Apple, you have a unified memory. So let's say if you have a 64 GB MacBook, so that means you can load models that I cannot on my Windows PC. So that's where the trade-off happens. But it's not necessary that having a Mac is going to have bigger models, so it's going to be good. Because if you have a GPU, it means we've got faster models. So with fast models, you can get replies quickly, but on Mac, you can have bigger models, if that makes sense. Now, what each model size actually costs. So if you're on a VRAM of 8 GB, you can easily run models which end in 7B. Or if you're like me on 12 GB VRAM, you could easily run models which end in 14B. And so far, you can just go on and on depending on your VRAM. Now, if you're on a Mac OS and if you think you can run a 70B model, let me correct you there, because even if you are on a 64 GB memory, it's a unified memory like I mentioned before. So what happens in a unified memory is your system still needs some space to be able to run other processes that are useful to keep your PC running, if that makes sense. So it's not that you can actually run the 70B models as well. Now, depends on your hardware. It's just going to show you model tier table. So if you're on a 8 GB VRAM, the normal basic chat model would be Qwen 2.5 coder 7B. And this is the autocomplete tool. Basically, it completes your codes if you're using a VS Code or something like that. And if you're on a 12 to 16 GB VRAM, you can go for a Qwen 2.5 coder, but a 14B. This thing in the end is what is making the difference, the B. And if you're on a bigger VRAM, that's how it keeps increasing. So that's that. And I've got like exact hardware recommendations as well. So if you're on a 16 GB MacBook, if it's an old one, you can still run the 7B model. If you're on an M4 Pro, you can use this one. The newer version, Qwen 3 coder, is actually better, but that 30B only works on certain devices, so you might have to check that. And this is a list if you want to take a screenshot and keep it for your use for next time. So basically, autocomplete and chats have different job. Autocomplete fires on every stroke. It needs a tiny fast model. That's why I'm going for something like 1.5B would make sense. Otherwise, it will just feel laggy and so slow. Chat and edit. This is the main feature we need. So this is what we trigger manually. It can be big and smart because you'll have to wait a bit for it to load. And always size down if your machine is smaller. Like I said earlier, if you're on a 64 GB Mac, don't try to run models that are too heavy. Leave some space for other things as well. And a slow model isn't a broken setup. It's just the wrong size for your hardware. So just keep that in mind as well. And another thing that I wanted to go over is quantization. And I feel like this is really important to know just before you get into choosing your local LLM. So I'd seen this word quantization before, but I never really sat down with it. So I never really knew what it meant. But here's what it actually means in the simplest version that I could find. AI models are big, basically. So Llama 3.1, 8 billion parameters at full precision is 16 gigabytes. Now, Llama 70 billion is 140 gigabytes. There's no consumer GPU on the planet with 140 gigs of VRAM. So we have to compress. That's what quantization does. The numbers that make up the model, by default stored at high precision, called FP16, get rounded down to lower precision. So models get smaller, they run faster. Just the thing is, the quality drops slightly, but I think it's worth the trade-offs that we are going through. And the amount of compression is what those codes means. So if you see a Q8, Q5, Q4, Q2, it's all coming from that. Right, so we are inside LM Studio right now, and we're gonna see what it actually looks like. So I've gone through the installation and done it already. This is where we can see developer docs, or if you want to load a model. Currently we do not have any, so let's go through that. This is where all our models will be appearing once they're done. And to begin with, I'm just gonna go over here and see what could run for me. So I already went and searched that, and according to my VRAM, I'm just gonna go with the Qwen 3. And let's see. So what all have they got? Actually, I'm just gonna complete it all. Actually, I'm gonna go for 8B for now, because I'm not really sure if that is going to work that well, but yeah. So once we come over here, we can see we can choose the models. And what happens over here is we can see this quantization levels over here, which we spoke about earlier. And what's this KM at the end? That's the specific quantization method. The K-cons are smarter than the older formats, so they keep the important weights at higher precision and compress the less important ones harder. So for most people, Q4KM is the right starting point, and which that is the one that I'll be going with as well. Because if you think about it, all these models exist at different sizes, but this one has been quantized to the most least size possible. So the only thing is we're just gonna trade off the quality, but it's not gonna make that much of a difference. So while this downloads, I'm just gonna quickly maybe try downloading some other model. Maybe let me see, what can I go for? Let's go for DeepSeek. Why not? And I've already seen what would work for me. You can go to ChatGPT or Claude and give it your hardware specs, and then it might be able to tell you what the best model for you is. So this is the one that I'm gonna go for. And then again, we spoke about the quantization level, and this seems like the right ideal choice for me. Let's go. Just gonna download this as well. So both are getting downloaded, and while we wait, let's just go to the settings and let's see if we can find something useful over here. Okay. Right. Forgot to mention one another thing. So while this gets downloaded, okay, not specifically this one, but when we go back to Qwen, let's say any model. So these capabilities are something that you can look out for. Obviously now I know most of us cannot be running this model, but I'm just saying some of the lower tier models like this, see, even this one has, oh, let's just go for something even. Okay, let's go for this one. So we need to see like what are the capabilities and if it has tool use. So basically tool use is where it allows the model to call tools to do tasks for us. And it could be anything. It could be maybe call a PDF or open something in the browser or a calculator, anything. And this thing over here is the reasoning. So it's going to think a lot and then give you the proper steps of its thinking and then give you the response after that. Okay, as you can see, one of the models is already downloaded. We'll just wait for the other one to download. I just want to mention one more thing, that there are other models. This one's by Google. But for coding, I would always suggest Qwen, because I feel like that has the most accurate answers to your coding problems, or it just does better than Gamma 4, and that's my selection for it. And honestly, you'll just have to play around with all the models that are out there, and then you'll just have to find out what works best for you. And you can always check on Claude or ChatGPT. Just work around with what you've got. So let's see, our models are already downloaded. Is this one done? Okay, just wait for a couple of seconds more. All right. So this is the chat function. This is where we can go and we just pick our model from here. And we're just gonna pick this one. And so over here, we can select what our context length is. And what I would normally do is push it up as much as possible. But as you can see, my GPU does not allow me to do that. So mine would be 12. So I would just leave some space over there. Mine is 12 gigs. So I'm just gonna go with maybe around this much. And GPU offload can also be, at somewhat max level. Then you don't need to play with anything else. Just load model and let's test it out. I haven't finished loading the model, so let's just wait for that and let's see how long it takes to respond back. As you can see, everything is streamed. Let's ask it. I'm good, thanks. What can you do for me? Yeah, if you ask me, that's pretty quick, the responses that we are getting. I just want to know how many tokens it is per second. Let's just wait for it to finish. Alright, so it can answer questions for us, like stories, and all that things that any LLM can do. Basically all of that. So I just check over here. It's supposed to tell me how much tokens I had. It's weird. It's not working. I don't know, for some reason. But with the speed, I think I can say that it's pretty good. It's around 100 tokens per second. That's good. We have increased the context window as well, so that only means it's going to work good because it's going to remember more about what you have said. So that's always good. All right, I just felt like doing some testing as well, just to see if it would work. So let's ask it to write us a Python function that fetches all CSV files in a directory, merges them, and removes the duplicate rows. Why not? Also include error handling. Let's see how it does. Sitting at about 75 tokens per second, I think. Roughly the throughput my 5070 should hit on an 8B model. It's faster than I read, honestly. Alright, let's look at the code. Okay, let's see the function which we all care about. Function looks decent. Code looks clean, to be honest. The try, okay, let's let it finish. Because it has started with try. I just want to see if it does accept as well. Yep, it does. So the try accept block look good. Right. So I think it's also handling the missing values as well. The missing directories. Okay, all in all, that's usable code, and it was the first try. Why not? That was pretty good according to me, and it didn't take that long. Okay, once it's done, I'm just gonna go for another test just to see how it does in some other domain. Let's keep the question ready. Let's keep it something simple and something that we have been talking around across this entire video, so it makes more sense. Explain the difference between quantization 4 and alright, great question. All of that AI slop. You're asking about the two different quantization schemes used in AI models. blah blah blah, which are commonly seen in LLM quantization tools like GTUF, llama.cpp, which we went through earlier, or Hugging Face's llama.cpp. It has the same frameworks. Okay. Let's see what it has for us. Yeah. Showing the quantization level. It's made a table for us. Too long didn't read. Kind of vibe. I like it. Okay. The thing is, right, since it is streaming, it gives a perception that it's not slow as well. And this is what most of the LLMs do. If you're talking about ChatGPT, if you're talking about Claude, everyone is just streaming their text because that's the main concept, right? If we are waiting on a blank screen for the response, it's gonna take so long that we're gonna feel it's slow and it's laggy. But these guys know the trick. Just stream everything, so everything seems fast. It's just the perception that everything is coming to us one by one. That's why if you feel like, okay, it's not slow, something is happening. But in reality, you know the truth. Right. Okay, so it's telling me everything. It's a decent explanation overall because it's gone into deep dive what it actually is. It's explained the KM, the quantization, the trade-offs. Same thing for the Q5, how quantization works, when to use which. All in all, it's a pretty decent explanation. And we can't really forget that it's a local model explaining quantization. So it's a big moment there. Right, all right. Nice. Okay, so that's done. So a clean explanation from a local LLM. Can't really complain. So let's go to this and switch our model to DeepSeek. Crank it up a bit. I think this should be okay. Okay, why is this? Right. So we need to crank this up almost till max. I usually don't keep it at max. I'm just gonna keep it a bit low over here. I think this should be okay. Let's load the model, and while the model loads, I think we're gonna have to think about another question. Okay, it's already loaded. Let's just quickly see the settings, how it's doing. Right. These other things don't really matter to us. What matters is the context length and the GPU offload, to be really honest with you. All right. Let's go with question. So since it's DeepSeek, I really want to check the reasoning tool behind it. So if I have 12 GB of VRAM and run a 13 billion parameter model at decent quality, which quantization should I use and why? Right. So look at this. These think tags, right? That's the reasoning chain. DeepSeek R1 thinks out loud before answering. That's the model literally working through the entire problem. It has a different architecture and different strength. So again, that's local AI working on my laptop to prove it's really local and it's cool in my perspective. Now I know it's gonna run. I'm just gonna disconnect it. So right now it's just text in, text out. That's just the start, not the entire goal though. Next video, I'm gonna give this thing a voice. I'm gonna use Whisper for speech to text. I've been meaning to check that out. It's an open source text to speech model for it to talk back. So then I can speak to it and it will speak back to me, and all of it will run on the same machine. And after that, maybe I want to wake my whole laptop up, which I was talking about in the start of the video, and turn it into a secondary AI node maybe. So the whole setup will talk across itself between both the machines. So that's another view as well. So yeah, guys, if you're building something like this too, or even thinking about it, just drop a comment with which model you've picked or your VRAM, and I'll tell you what would actually fit. I'm figuring this out as I go, and it's more fun to do it with people doing the same thing. So thank you guys. See you in the next one.